I wanted to give you a hint about one of the homework problems that's a little bit harder than the others. And this is the one, actually, it's, I think, a pair of questions that have to do with this photographer who faces a daily demand curve that's given in a tabular form, so numbers in a table, not this smooth demand curve that I'm going to talk you through the problem with. I'm hoping to give you a hint without giving the problem away, so I'm going to give you the hint in the context of a graph, and the lessons from the hint apply directly to doing the problem in a table, calculating marginal revenue just by multiplying price times quantity to get total revenue and look at the difference for marginal revenue. Anyway, so the game here is that George is this photographer. He can predict his daily demand, that he sees because he's got a lot of experience and it's pretty much the same every day by assumption. And he's got this cost of offering each photo shoot that's just constant. All right, so he's a monopolist. He can charge the price. He's the only photographer in town. And in any case, he faces this. He knows if he charges a high price, he knows he's going to get one photo shoot. A lower price, he'll get a second photo shoot, etc. He knows this, so that whether he's a monopolist or not, he faces this downward sloping demand curve that he knows about. All right, so let's think about what price will he sell if he can only if he can only charge his customers one single price. So that is going to be our usual case for analyzing a single price monopoly. It's the same as the potato cartel we just talked through. And we'd look for the marginal revenue curve that has the same y-intercept and is twice as steep. I've marked the midpoint between the origin and the x-axis intercept. I don't have numbers drawn. It's because I don't want to give the problem completely away. All right, get that one right, and this one looks right. So that's my marginal revenue curve. Let's go ahead and label that. I need to match colors. All right, so this is George's. I can't remember the name of the guy in the real problem. It might be George, might be something else. But anyway, that's his marginal revenue function. And so if he's a single price monopolist, this is just review right now, but I'm going to build the price discrimination case off this. If he's a single price monopolist, he produces the quantity where marginal revenue and marginal costs are the same, and he charges a price based on what the market will bear. I got to move that line around. Let's see if I can't do that right. There we go. I don't know if you could see that. My drawing software was giving me just this weird set of options. That's not horizontal. It needs to be perfectly horizontal or close to horizontal. All right, so that's the single price monopolist price. Call it capital P, small m. And that's the single price monopolist quantity. We'll call that very imaginatively big Q sub m. And there we have it. So now the problem gets a little interesting. And the question goes on to ask, well, if nobody that would pay PM or higher would use a coupon, but everybody that has a lower willingness to pay would use a coupon, what should be the coupon price? And the way to do this problem is to just see this group of potential coupon users as their own separate market. So I'm going to suggest, you do the tabular equivalent, but the way you do this is just imagine these leftover people as a completely separate market. So they have a new price axis that is this red. I'm trying to make that vertical. That's pretty good. They have this new price axis for this smaller demand curve, I'm just going to think about this portion of the demand curve as a separate demand curve. So we'll label that P, and we'll move that over so it's, there we go. All right, so then I've got these leftover customers that I can treat as a separate market, the market of potential coupon users. And that separate market is going to have a separate marginal revenue curve. And so let's draw that. It's going to have the same y-intercept. It's going to be twice as steep. I didn't count these squares, so I'm going to rough it. Let's get that to line up right. And this market is going to see a separate point where marginal revenue and price intersect. And that's going to be, I'm going to find that point by calculating out the marginal revenue just for the coupon users, if treating that as a separate market. That's what price discrimination does. Price discriminators do. They separate markets. Senior citizens, one market. The rest of us, the other market. And then there's going to be, oh, I still had that highlighted, so it moved the line instead of creating a new line. Now I've got it. There's going to be a coupon price. And let's make sure that line is a little closer to horizontal than it came out the first shot. All right, so we'll label that, and we'll call it P, and then not, for lack of, I'm going to just write out coupon. And let's move that over. And the quantity of coupon sold, notice that there's this higher quantity. Notice that just this horizontal distance gets us the number of coupon tickets. So the total shoots he does are the number that people pay the full price for, plus the number of coupon shoots. So I'm going to just label that QM prime, the new output that includes both the full price pairs and the low price. And if we wanted to identify just the quantity that of coupon sales, it would be that little short segment in red. And then the problem goes on to ask you for consumer surplus in the single price monopolist case, actually total surplus. And we see that total surplus for the single price monopoly case is this triangle of consumer surplus, and you'd be calculating that by looking at the difference in willingness to pay minus the price for 1, for 2, for 3. So it's a little different when you're doing it in tabulated form with discrete customers. And I'll expect to help people with that in my office hours. Anyway, you're asked to identify the difference in total surplus for the single price monopoly case. That surplus would be this triangle of consumer surplus plus this rectangle of producer surplus. And with that coupon scheme, notice that both consumer surplus increases, this new triangle of consumer surplus accruing to coupon users is so consumers are better off with the price discrimination, and the producer also picks up a little more surplus. So the point that the ability to price discriminate increases efficiency is an important one. So that's how you do that. By the way, I guess this is a point to note that in the extreme, we might have a producer that can tell everybody's reservation price and can keep one customer from selling the good to another customer. Indeed, a photography studio could I have no interest in the pictures of my neighbor's kids. I want my own kids. So there's no risk of eroding one customer's interest in buying a photo shoot by giving a low price to another customer. There's no risk of resale. But anyway, let's suppose that George can tell, the willingness to pay of every single person that walks in the door. Well, then he'd give everybody a price that was equal to their highest willingness to pay, and he'd serve every single customer. That's actually the efficient quantity is where everybody that values a photo shoot at a price greater than or equal to the marginal cost of providing it gets a photo shoot. So a perfect price discriminator will produce actually the competitive outcome, but everybody will have paid their reservation price, and so this whole area will be the surplus, and it'll all be producer surplus because everybody paid their maximum willingness to pay. There's just a few industries that function in that way. One is jewelry store. Everybody that walks into a jewelry store, the sellers are willing to negotiate a price based on the bargaining ability, the willingness to pay of each person that walks in the door. Art galleries are similar. You might wonder who would pay those huge prices they've got pasted on the frames of these paintings. Nobody is the answer. Anybody that buys art knows they walk in and see a painting marked at $6,000 that they might be able to get out of there with paying $2,000 for that painting, whatever. Some still out of my budget, but art buyers tend to be richer than me. Anyway, that perfect price discriminating case is sort of the limit of how much a seller can get out of buyers, and so that's sort of an interesting theoretical case. All right, let's call that long enough of a price discrimination technical analysis screencast.